And now for the next part of our discussion on optics, we have reflection and refraction of light. As previously mentioned, light does not require a medium in order to exist and travel or propagate, but light can travel through a physical medium. Light can travel through air, it can travel through water, and so on. If you have two media, medium 1 and medium 2, the border between the two media is referred to as the interface between the two media. Light traveling in one medium, there's a chance that light will encounter the interface between the two media. When light encounters or is incident upon the border or interface between the two media, one or both of the following will happen: reflection of light and refraction of light. If both happen at the same time, part of the light will be reflected while the remaining part will be refracted. For example, if 30% of the light is reflected, the remaining 70% will be refracted. First, let's take a look at reflection of light. Reflection of light happens when light rebounds or bounces off the interface. So you have incident light, light striking the interface between the two media, medium 1 and medium 2. You have the interface, you have the normal line, the dashed line. The normal line is perpendicular to the interface. You have incident light. It has angle theta 1 with respect to the normal line. Theta 1 is referred to as the angle of incidence. The light will bounce off or rebound or reflect off the interface. You have reflected light. The reflected light has angle theta 2 with respect to the interface. Theta 2 is referred to as the angle of reflection. The law of reflection tells us that the angle of reflection is equal to the angle of incidence. The two angles, theta 1 and theta 2, are equal. Theta 2 is equal to theta 1. Law of reflection. On the other hand, you have refraction of light, also known as light transmission. Refraction of light happens when the light passes through the interface. So you have medium 1, medium 2, you have the interface between the two media. You have incident light. Instead of bouncing off the interface, the light passes through the interface. You have refracted light. You have the interface, you have the normal line. Incident light has angle theta 1 with respect to the normal line. Theta 1, angle of incidence. You have refracted light, angle theta 2 with respect to the normal line. In this case, theta 2 is now referred to as the angle of refraction. The relationship between theta 1 and theta 2 is given by the law of refraction or Snell's law. Snell's law tells us n1 sine theta 1 is equal to n2 sine theta 2. n1 is property of medium 1, n2 property of medium 2, n, whether n1 or n2, n is referred to as the index of refraction of the material. So n1, index of refraction of material 1 or medium 1. N2, index of refraction of material 2 or medium 2. And the index of refraction has no unit. It is the ratio between the speed of light in vacuum and the speed of light in the corresponding medium. So N is equal to speed of light in vacuum divided by speed of light in the medium. N is equal to C divided by V. So N1 is equal to C divided by V1. N2 is equal to C divided by V2. V1, speed of light in medium 1. V2, speed of light in medium 2. From V1, the speed of light becomes V2 when light passes through the interface. When light moves from one medium to another. Thus, when light moves from one medium to another, its speed changes. And this causes a change in the direction of light propagation. For instance, from this direction, the motion of light changes to this direction when light moves from one medium to another. This is basically what light refraction is. The speed of light changes as it moves from one medium to another. The direction of propagation of light changes when the light moves from one medium to another. We can say the light bends or changes in direction. The light bends when you move from one medium to another. It has been observed that the frequency of light is unaffected when light moves from one medium to another. So the speed changes, but the frequency of light remains constant. Light is a periodic wave. If we use the equation for speed of light for a periodic wave, V is equal to F lambda, V1, V2, F is constant, which means wavelength will change from lambda 1 to lambda 2. When the speed of light changes, the wavelength of light changes. Thus, we may also express index of refraction in terms of wavelength. N is equal to wavelength of light in vacuum divided by the wavelength of light in the medium. N is equal to lambda C divided by lambda V. Here are some examples of index of refraction values. You have index of refraction for vacuum, N is equal to 1. You have index of refraction of air, you have 1 or almost equal to 1 such that we consider the index of refraction of air to be equal to 1, which means the speed of light in vacuum and the speed of light in air are almost the same such that when in air, we consider the speed of light in air just equal to the speed of light in vacuum. C is equal to 3 times 10 to the 8th power meters per second. And then we have the index of refraction of water, 1.33. Under certain conditions, light that should normally refract does not refract. Instead, total internal reflection happens. Let's take the law of refraction equation. N1 sine theta 1 is equal to N2 sine theta 2. You have incident light and refracted light. There won't be any refracted light if we set theta 2 to 90 degrees. That is to say, no light will move to or pass through the interface and move into medium 2 if we set the angle of refraction theta 2 to 90 degrees. Going back to a previous figure, theta 2, if we set theta 2 to 90 degrees, the refracted light is here. No light will pass through the interface and into medium 2. No refracted light. So setting theta 2 to 90 degrees, you don't have refracted light. This equation then gives us N1 sine theta 1 is equal to N2. Isolating theta 1, we get inverse sine of N2 over N1. And we set this angle value to theta C, the critical angle. Note that for inverse sine of N2 over N1, for this to give you an answer, for there to be a value for theta C for the critical angle, N2 must be less than N1. That is to say, this quantity must be less than 1 for inverse sine to give you an answer. Try out N2 greater than N1, meaning N2 divided by N1 is greater than 1. Try to get the inverse sine of a quantity greater than 1. You'll get an error in your calculator, meaning no value for the angle theta C. So there only be a value for theta C if N2 divided by N1 is less than 1, meaning N1 must be greater than N2. Medium 1 must have a greater index of refraction than the index of refraction of medium 2. This 2 makes up the two conditions for total internal reflection to happen. The angle of incidence must be equal to or greater than the critical angle, and the index of refraction of medium 1 must be greater than the index of refraction of medium 2. When N1 is greater than N2, and the incident angle theta 1 is equal to or greater than theta C, the critical angle, no light will be refracted, no light will be refracted, and only reflection occurs. You have total internal reflection. If these conditions are not met, total internal reflection will not happen. You only get refraction of light. And that's it for now. That's it for our discussion on reflection and refraction of light. In the next video, we'll continue our discussion on optics. In the next video, we'll take a look at the concept of image formation. So again, that's it for now, and thank you for watching.